Hi guys, today's lesson is on Snell's law. So you've already learned that you can calculate the index of refraction using the speed of light in different mediums. But you can also calculate the index of refraction using angles. So using the angle of incidence and the angle of refraction, you can actually still calculate the index of refraction using the formula sine angle of incidence divided by the sine of the angle of refraction. So if you take the sine of the angle of incidence and divide it by the sine of the angle of refraction, you will get the index of refraction. So if you're ever given questions that give you the angles, you'll have to use Snell's law. So you'll notice that here I've inputted my values, so sine angle 40 divided by sine angle 28, and based on your grade 10 math course, you should know how to use these trigonometric ratios on a calculator. You're going to punch in sine 40 and you're going to get 0.64, and sine 28 will give you 0.47. I have rounded these to do 2 decimal places. Then when I do that division of 0.64 divided by 0.47, I'm going to get an index of refraction of 1.4. So the index of refraction is 1.4. And remember, the index of refraction has no units, so the final answer is just 1.4. Snell's law can also be used when you actually know information about the two mediums. So the medium that you start with, and also the second medium where the light is traveling to. So Snell's law is also the relationship between the angles of incidence and refraction and the indices of refraction of the two media. Snell's law applies to the refraction of light in any situation, regardless of what the two media are. So it does not matter in what media the light is actually traveling through. If you call the indices of refraction of the two media N1 and N2, so N1 is one of the medias and N2 is the other, and then you call the angle of incidence theta 1 and the angle of refraction theta 2, then you're going to get this formula. N1 sine theta 1 is equal to N2 sine theta 2. And this might seem confusing, but it's not. The left side of the equation is the media that you are starting with. So it's your first media. So it's wherever the light is coming from. The right side of the equation, that's the medium in which the light is traveling into, right? So light bends when it either speeds up or slows down. And this happens because it's traveling through two different media. So the left side of the equation is the first medium, whether that's air or water, whatever it may be. It's the first medium. It's where the light is originating from. The right side of the equation is your second medium. It's where's light traveling into. And remember, it could be speeding up or it could be slowing down. It has to do one of the two. There has to be a change in speed for light to actually bend. Okay, so let's take a look at the next practice problem. When light passes from air into water at an angle of 60 degrees from the normal, what is the angle of refraction? And you might be asking yourself, how do I know when I'm supposed to use one of, now you know 3 different equations. How do you know when you're supposed to use n is equal to c over v, or n is equal to sine angle I over sine angle r, or this new Snell's law, n1 sine theta 1 equals n2 sine theta 2? Well, it's really easy to figure out when you have to use which equation. If you know the speeds in which the light is traveling, then obviously you can use the first equation. Okay, so if you know the speed of light in the different mediums, then you can definitely just go ahead and use n is equal to c over v. If you know one of the angles, so the angle of incidence and the index of refraction, or if you know both the angle of incidence and the angle of refraction, you can use this second equation. Because remember, to solve for an unknown, you need 2 out of the 3 missing pieces of information. So to use this second equation, you would either need to know the index of refraction plus one of the angles, or you need to know both angles. If you don't know that information, if you don't have it, then you ultimately do have to use this last equation that incorporates the theories in Snell's law. So let's look at this question. When light passes from air into water at an angle of 60 degrees from the normal, what is the angle of refraction? Well, immediately I'm going to go and try and use my second equation because that seems a lot easier. So I know that the angle of incidence is 60 degrees, but I have no other information about the angle of refraction or the index of refraction. So can I use this equation? Not right off the bat. But I can use my last equation using the chart on page 524 of your textbook. That chart on page 524 of your textbooks gives you the index of refraction for various media. So by looking at it, I know that the index of refraction of air is 1.00, and I know that the index of refraction of water is 1.33. So given that the angle of incidence is 60 degrees, I can definitely find what the angle of refraction is. I can just substitute all these values into my formula. N1 sine theta 1, which is the angle of incidence, is equal to N2 sine theta 2, which is the angle of refraction. Okay, so here on the right-hand side of this slide, I am going to plug in all my values, which I've already done. So sine theta 1 is the sine of the angle of incidence, which is 60 degrees. I'm looking for my angle of refraction, so sine theta 2 is going to stay sine theta 2. When you plug in all your values and you do all your calculations, you're going to be left with 0.87 equals 1.33 sine theta 2. Now, you should know from math class that to isolate a variable, you need to rearrange the equation. So I need to get sine theta 2 by itself. So what I'm going to do first is I'm going to take this 1.33 and I'm going to bring it over to the other side of the equation. When I do that, I'm going to perform the opposite operation, which is going to become division. So I'm going to be left with 0.87 divided by 1.33 equals sine theta 2. When I do that calculation, it gives me 0.48 is equal to sine theta 2. Now, the question is not asking me for sine theta 2. The question is asking me for the angle of refraction. I know that the angle of refraction is theta 2. So how am I going to get theta 2 all by itself? Well, I have 0.48 is equal to sine theta 2. Again, from your trigonometry unit, you should know that to isolate the angle, you bring sine over to the other side of the equation. When you bring sine over to the other side of the equation, it becomes the inverse of sine. So now I'm left with the inverse of sine multiplied by 0.48 is going to equal my index or my angle of refraction. So again, you're going to plug that into your calculator, and remember, you can only figure out these calculations using a scientific calculator that have your trigonometric ratios there. When I do that, I'm going to be left with, when I round it, 29 degrees. So the angle of refraction is 29 degrees. Okay, let's do one last practice problem. In an experiment, a block of cubic zirconia is placed in water. A laser beam is passed from the water through the cubic zirconia. The angle of incidence is 50 degrees and the angle of refraction is 27 degrees. What is the index of refraction of cubic zirconia? So I'm going to write down everything I know. I know that the index of refraction of water is 1.33. I know that my angle of incidence is 50 degrees. I know that my angle of refraction is 27 degrees, and I'm asked to find the index of refraction, which is N2. I'm going to write down my formula, which is N1 sine theta 1 is equal to N2 sine theta 2, and I'm going to plug in everything that I know. N1, my first medium, is water, so the index of refraction is 1.33 multiplied by the angle of incidence, which is sine 50 degrees. That's equal to the index of refraction of my second medium, which I still don't know, so I'm going to leave it as N2, multiplied by the sine of the index of refraction, which is 27 degrees. When I multiply and rearrange this equation, I'm going to be left with 1.03 divided by 0.45 is going to equal your index of refraction. When you do that division, your final answer is going to be 2.3. So the index of refraction of that piece of cubic zirconia is 2.3. Now, I know that this can seem confusing, but the more practice that you do, the better you're going to get at it. So this brings us to the end of today's lesson. Please complete the practice problems attached, and if you have any questions, email me.